So good afternoon, everyone. Welcome to the week 9th of the Principles of Communication System. So today we will discuss the questions related to whatever is taught in the week 9th of the NPTEL tutorial session of this course, Principles of Communication System 1. So also this video will be recorded and uploaded on YouTube. If you have any doubt, you can comment in the YouTube also. So we'll start the lecture in 1 minute. So basically in this lecture, it is taught about probability and the random variable. So the first question is any subset of the set of all possible outcomes of a random experiment is termed as. So any subset of all the set of the possible outcomes of a random experiment is termed as event. So option C is the correct answer for this question. And also we'll see some of the basic things. So like information source are random. So like information bits which are transmitted. Let's suppose that transmitted is 0, 1, 0, 0, 1, 0. So the next bit is completely random. So information symbols are random in nature. Now let's suppose sample space. So sample space what it is? Let's suppose we have thrown two dice. So what will the sample space for this? Sample space will be like this 1, 1, 1, 2, 1, 3, 1, 4, like this. Then again 2, 1, 2, 2. Like this, it will go up to 6, comma 6. So the sample space is S here. And now what is S? Set of all possible outcomes of an experiment. So S is set of all possible outcomes of an experiment. Okay. So this is very simple. Like when we throw two dice, what happens? The what is the set of all possible outcomes? Like from 1, 1 to 6, 6. Like let's suppose one appears on one dice, then on another dice it can appear 2, 1, 2, 3, 4, 5, 6. So like that, there will be total 36 outcomes. Okay. Now let's suppose 1, comma 3 occurs. After throwing a dice, 1 comma 3 occurred. So in the first dice it occurred 1. In the second dice it occurred 3. Okay. So this is 1 comma 3. So this is just an event. So 1 comma 3 is just an event. What is event? Event is any subset of S. So for this question, the correct answer is event, like any subset of the set of all possible outcomes of a random experiment is termed as event. So now moving on to the next question. Before that, we will see the axioms of probability. So this question is very simple. So before that, we'll see the axioms of probability, some of the concepts which were taught in this week. So the probability measure of any set A satisfies three axioms. So axiom 1, the probability of an event A will be always greater than equal to 0. Axiom 2, probability cannot be negative. Probability of sample space is equal to 1. Means probability of all the outcomes like in the sample space that will be equal to 1. Axiom 3, probability of A union B is equal to PA plus PB. This will satisfy only if A intersection B is equal to 0. This means this is A and this is B. Here we can see that A intersection B is equal to 0. So probability of A union B is equal to probability of A plus probability of B. Now let's suppose take a case like this where A, B is there. So this part is the A intersection B. So now probability of A union B is equal to probability of A plus probability of B. So now this part will come twice. So we have to subtract one time the probability of A intersection B. Okay. But if probability of A intersection B is equal to 0, if probability of A intersection B is equal to 0, then P of A union B is equal to P of A plus P of B. Okay. So this so now we will move on to the conditional probability. So in this question, they are asking the conditional probability P of A such that B has occurred, the event B has occurred is. So conditional probability of A given B. So this can be also called as probability of A given B. So that is P of B has occurred, probability of A such that B has occurred is equal to probability of A intersection B divided by probability of B. Okay. So the correct answer is option number D. Okay. So also we can write it as probability of A such that B has occurred into probability of B, that is equal to probability of A intersection B. So the correct answer for this question is option number D. Also, let's see here, probability of A intersection B can be written as probability of A such that B has occurred into probability of B. Similarly, probability of B such that A has occurred. This will be probability of B intersection A divided by probability of A. So it implies that probability of B such that A has occurred into probability of A, that is equal to probability of B intersection A. So we can write from this equation 1 and 2, like both are equal, probability of A intersection B, that is also equal to probability of B intersection A. So we can write probability of event B such that A has occurred into probability of A, that is equal to probability of A such that event B has occurred into probability of B. So from here, we can write probability of event A such that B has occurred, that is equal to probability of B by A into probability of A divided by probability of B. So these are some of the formulas to be known in the probability. So we'll move on to the next question. The next question is, consider a uniform quantizer with 128 quantization levels and maximum masses amplitude is 1000. What is the quantization noise power? Now first we have to find the number of bits required to quantize the quantizer having 128 quantization level. So we know formula. So that is also known as resolution formula. Resolution R is equal to log 2 of quantization level. So here in this question, 128 quantization level is given. So when you put here 128, R is equal to log 128 base to the 2. So it implies that it will become 2 to the power of R is equal to 128. So what will be the value of R here? So it implies that R is equal to 7. So 7 bits are required for the 128 quantization level. Now it is given that maximum message amplitude is 1000. Maximum message amplitude is given as 1000. So from here, what we can do, so we have to find the quantization noise power. So quantization noise power can be given as sigma q of square. So from the like we have studied the formula of quantization noise power as derived in the lecture is minus 10 log base 10 to the 3 plus 20 log 10 maximum message amplitude minus 6R. So this is the formula for the quantization noise power. So we have to substitute the value and we will get the answer. So just substitute. Now after substituting, what will be the answer here? So the quantization noise power is equal to minus 10 log 10. 3 will be minus 4.77. Okay. And 20 log 10 is log 10,000. So this will become 3 minus 6 of R. So R is here 7. Okay. R is the number of bits required. So that is equal to 7. So when we substitute, we will get minus 4.77 plus 20 into 3, 60 minus 42. This will be 18 minus 4.77. So that will be equal to 13.323 dB. And this formula is in dB. So we will write here dB. So the correct answer is 13.23 dB. So option A is the correct answer for this question. So now we'll move on to the question number 4. So in this question, it is asking if two events A and B are mutually exclusive, then which of the statement is always true? So the correct answer will be option number D, because for the mutually exclusive events, P of A intersection B is equal to 5, like is equal to 0. So two events A comma B are mutually exclusive if A intersection B is 5. So if A intersection B is equal to 5, so A and B have no common sample points. So it implies that A comma B have no common sample points. So what will be the value of P A intersection B? That is equal to 0. Okay. So just remember this, that two events A and B are mutually exclusive if there is no common sample points between those events. So the correct answer for this question is, if two events A and B are mutually exclusive, then which of the following is true? So P of A intersection B is equal to 0. So option D is the correct answer for this question. Okay. And also these videos are recorded and will be uploaded in the YouTube. So now we will move on to the next question. Question number 5. The quantity P of A union B can be expressed as. So let's suppose this is our A, this is our event B, and this is the P of A intersection B. And let's suppose this is our sample space S. So within S, A and B is there. So first let's check the first option, P of A intersection B bar plus P of A intersection B. So let's see. Uh, I don't know why it is not copying. Hmm. So now here, see, I'll take some other color pen. The first is A intersection B bar. So B bar is the complete this. A intersection B bar will be this yellow. So this is A intersection B bar. Okay. Now A bar intersection B. A bar intersection B will be this. So when you add these two, so this is not equal to, here you can write, this is not equal to P of A union B. So option 1 is wrong. Now again, we will check for option 2. So option 2 is P of A union B is equal to P of A intersection B bar plus P of A intersection B plus P of A bar intersection B. So now you see, this is P of A bar intersection B. Okay. Now this red part is P of A intersection B bar. Okay. And now this black part is P of A intersection B. So when we add the reason 1, 2 and 3, let's suppose this is reason 1 and this is reason 2 and this is reason 3. So let's add now 1 plus 2 plus 3. So this is equal to P of A union B. So this option is the correct answer. So option B is correct. Okay. Understood? You can check the remaining options like option C and option D. That is incorrect. So we can check also. Let's see. The option C is incorrect because here it is a minus symbol. So 1 plus 2 minus 3, that is not equal to P of A union B. So option 3 is wrong. Now come for option 4. A bar intersection B bar. So A bar is the complete this, B bar is the complete this. So A bar intersection B bar will be this area. So this green area is A bar intersection B bar. And PA intersection B is the black area. So this option is also wrong. So option 4 is also wrong. The correct answer is option number B. Okay. We can solve this question by looking at the Venn diagram. This is also known as the Venn diagram. We will move on to the next question. That is question number 6. Before that, let me check once whether the videos are recording or not. Yes, it's recording. Now coming to the question number 6. So the question number 6 is, which of the following is not one of the axioms of probability? So we have studied the three axioms. Here you can see P of A is greater than or equal to 0, probability of sample space is 1, and P of A union B is equal to P of A plus B if A intersection B is 5. So here we'll write all the axioms again. Axioms number 1, probability of event A is always greater than or equal to 0. Axioms 2, axiom 2 is probability of sample space is equal to 1, and axiom 3 is probability of A union B is equal to probability of A plus B, probability of A plus probability of B if A intersection B is equal to 5. So come now the option A, for an any event probability of A is greater than or equal to 0, so option A is correct. Probability of the sample space is equal to 1, option 2 is correct. For mutually exclusive events, probability of A union B is equal to probability of A plus B. Option C is also correct. For mutually exclusive events, probability of A intersection B is equal to probability of A dot probability of B. So this is wrong. So which of the following is not the axiom? So this is not the axiom. So the correct answer will be the option number D. So option D is not the axioms of probability. Okay. So we have solved the first six questions. So now moving on to the question number 7. In the delta modulation, the distortion that arises when the step size delta is large in comparison to the signal that is relatively flat is termed as. So that is termed as a granular noise. Okay. So that is termed as granular noise. So option number B is the correct answer for this question. Now we'll move on to the question number 8. Consider a superhet receiver with broadcast frequency FC is equal to 3 kilohertz and intermediate frequency FIF is equal to 1 kilohertz. The corresponding local oscillator frequency that is larger than FC is given as. So FC is equal to 3 kilohertz f of if is equal to 1 kilohertz. So now that is asking fc, flo that is greater than fc, what will be the value? So flo is equal to fc plus f of if. This is the formula. So that will be equal to 3 plus 1 kilohertz. So the answer will be 4 kilohertz. So the local oscillator frequency that is larger than fc is given as 4 kilohertz. So option A is the correct answer for this question. Okay. So now we will see if two events A and B are independent, then which of the following statements is always true? So when two events is independent, the probability of A intersection B that is equal to PA into PB. Okay. So for this, the correct answer is option number D. So basically, what is independent events? Two events A and B are statistically independent if probability of A such that B has occurred is equal to probability of A. So we'll write the definition. Two events A comma B are statistically independent if probability of A such that B has occurred is equal to probability of A. Okay. So this means occurrence of B has no effect on the probability of occurrence of A. What does this mean? Occurrence of B has no effect on probability of occurrence of A. So we'll prove how this formula we can write. So if probability of A such that B has occurred is equal to probability of A, and also we know that probability of A intersection B by probability of B is equal to probability of A such that B has occurred. So now this will become probability of A. So from this we can write probability of A intersection B is equal to probability of A into probability of B. So option D is the correct answer for this question. Understood? So we can generally write this probability of A such that B has occurred is equal to probability of A. Why? Because occurrence of B does not affect the probability of A because both are independent. Similarly, probability of B such that A has occurred, what will be this equal to? Probability of B. Because probability of B does not depends upon the occurrence of A. So this is the important thing we should remember. And this is for when A comma B are independent events. So done. Now we will move on to the question number 10. So in this question it is given, consider the probability density function of the samples of a signal given as f of m is equal to sine 2m. Here the value of m is from 0 to pi by 2. So what is the optimal quantization level corresponding to the interval 0 to pi by 2? So this is given as sine of 2m, and the value of m varies from 0 to pi by 2. So now integration of 0 to pi by 2 m into sine 2m dm, that is equal to minus m by 2 cos 2m 0 pi by 2 and plus 1 by 4 sine 2m 0 to pi by 2. Now substitute the value, we will get minus m by 2 cos 2 into pi by 2. So that is equal to pi minus minus plus m by 2 cos 0 plus 1 by 4 sine of pi minus 1 by 4 sine of 0. So this term is equal to 0. This term is also equal to 0. This will be minus m by 2 into minus 1 plus m by 2 into 1 and plus 0. So this will become m by 2 plus m by 2. So this is equal to m. Sorry, we have to substitute the value of m also here. So we cannot write m here because m is pi by 2 to 0. So this will become pi by 4. Okay. So now we will get pi by 4 plus pi by 4. So this is equal to pi by 2. So the optimal quantization level corresponding 0 to pi by 2 can be found as following. So this is equal to, so what will be this integration? This will be sine 2m dm, that is equal to cos 2m by 2, and it is 0 to pi by 2. So this value is equal to cos pi equal to minus 1 by 2 minus of 1 by 2. So this will be equal to minus of half. So here, when we do this integration, the value will become pi by 2 divided by 2. So that is equal to pi by 4. So hence, because this integration will be minus of cos of 2m 1 by 2. And when you will put 0 to pi by 2, the value will be minus of half cos pi minus and minus will become plus of half cos 0. So this will become minus half into minus 1. So this will be 1 by 2 plus 1 by 2. Something like 1 it will become. So this value is 1. Here I have done some mistake. The above value will be pi by 4. So the final answer will be for this question is pi by 4. So I think when we find this, here this will become pi by 4. This integration is going to become pi by 4. So the correct answer is option number A for this question. So this today we will end up here only. This video is recorded and will be also shared on the NPTEL portal, and also the PDF will be shared. So thank you everyone for attending the today's lecture.